Welcome to week 12 office hours. I'm going to do some homework. Let's go to the weekly homework. And let's continue working on proofs. Okay, so the first question is asking us to figure out what rule would allow us to derive the conclusion in question. So we have a conditional, the main operator is the horseshoe. We have two rules that apply to conditionals, modus ponens, MP, and modus tollens, MT. So does this look like either of those patterns? Well, we have a conditional, we have the antecedent of that conditional on a line, and we've concluded the consequent of that conditional. So this is either modus ponens or modus tollens. Which one is it? The next one, again, has a conditional statement. The main operator is the horseshoe again. So is it modus ponens or modus tollens? We have the negation of x, and x is the consequent of this conditional, and then the conclusion is the negation of the antecedent of the conditional. So this is either modus ponens or modus tollens. Okay, the next one has a disjunction as its main operator. Which rule applies to disjunctions? Modus ponens, modus tollens, disjunctive syllogism, simplification, or conjunction. So we have a disjunction, we have the negation of one disjunct, and then the other disjunct is on line 3. So what rule could we use to derive that? Hint, disjunction. Disjunctive syllogism is a rule. Okay, next. I notice we've got an atomic statement, a negated statement, so there's no conditional or disjunction. I see that the thing that we have derived or put on a new line or concluded is a conjunction. One rule allows us to make a conjunction, and one rule allows us to essentially take a conjunction apart. Which one is which? The conjunction rule allows us to make a conjunction, simp to take one apart. So this one is going to be, we've made a conjunction. If this is true and this is true, then we know this conjunction is true. And here we have a conjunction, and we have derived just one of those conjuncts. We know that if this conjunction is true, then both conjuncts are true, which means this one in particular is. So this one will be conjunction, this one will be simp. Okay, then I'm going to skip questions 2 and 3 because these are similar to previous homework questions. Your task is to figure out which one of these are correct applications of modus tollens. And so a couple of quick hints. Modus tollens only applies to conditional statements, and the horseshoe, the conditional part, has to be the main operator. So we can already see that this is not a conditional statement here. Modus tollens can't be applied to parts. This is a disjunction, so that's not going to be applicable. These ones at least involve conditional statements. This one doesn't, so that's not going to be applicable. And recall that for modus tollens, we're looking for a conditional, the negation of the consequent only, and we conclude the negation of the antecedent. Here, I'm looking for a special case. So maybe look at this case right here. We have a conditional, we've got the negation of something, but it's not of the consequent, right? It's of the antecedent here. So this one won't be a case. So follow not the schematic diagram of the rule, but write out the actual rule, which says if you have a conditional and you have the antecedent of that conditional, the exact same thing on a new line, then you can put that's the rule for modus ponens, but for each rule, write out the actual rule. That's what you're looking for. And so similarly for disjunction, this only applies to disjunction, so we can already see right away this first one here, this is a conditional statement. It's not going to apply to that. Okay. So let's do a proof together. Question 5, you're merely asked to fill in the justifications for the proof. So if you know we've derived A, and we are citing line 3, look at what line 3 is here. It's A and B. What rule would allow us to derive A from one line, line 3? We've derived one conjunct from this conjunction. Hint, it's simp. Now we're citing line 3 again, and we've got the other conjunct. So we use the same rule on this, on the same line twice. So we derive each conjunct on its own step. Okay, so now we've got this new thing. How do we get that? Well, what's line 1 and 4? 1 is this conditional. Line 4 is one of our derived lines. It is the antecedent of the conditional, and the thing we got is the consequent. So what rule allows us to derive the consequent of a conditional? Next we have this not x. We're looking at lines 2 and 5. Here's a conditional. Here's the negation of the consequent of that conditional, and what we've got is the negation of the antecedent. So which rule allows us to get that? And then finally, we've somehow derived y from lines 6 and 7. That's these two lines. What rule allows us to get we've ultimately derived a disjunct out of this disjunction, right? And we've got the negation of the other disjunct. What rule would allow us to do that? Question 6 is the opposite. You're given the lines and the rule, and you have to figure out what you can derive. So we've got our first one is done for us. We're looking at line 3, and we've used simp. If this conjunction is true, we know that not x has to be true as well. The next line cites 2 and 4, so we're going to look at this disjunction. That's line 2. Line 4 is the negation of one disjunct, so what does ds say we can put on the next line? So I'll leave you to finish that one on your own. Question 7, remember to follow the formatting rules, especially the not including any spaces, so that AutoGrade gets it right. Okay, so we've got a proof here. I'm going to leave this easy one for you to do. Let's start. This one's probably pretty, well, this one's maybe a smidge harder. So let's do 8 together. Okay, so how should we reason through this? So one thing you can do is start with what you're given and just apply any rule that can possibly apply. So we might say, I have a conditional. That already signals like I could maybe use modus ponens or modus tollens. What would I need to use modus tollens? I would need the negation of the consequent. So I'd need not z somewhere. I don't have that. Okay, that rule doesn't apply. The other rule that applies to conditionals is modus ponens. If that rule applies, I would need to have the antecedent on its own line. Do I have w and y on its own line? No, so I can't use modus ponens. But I do see that I have y and w. So I'm thinking maybe I could make the antecedent and then get to z. So that's my strategy of just apply any rule I can. The other strategy is to work backwards. I know I ultimately want to derive z, so I'm going to put that here right now. How am I going to get z? Well, z is the consequent of a conditional. One rule allows me to derive the consequent of a conditional, modus ponens, and that rule that's only if I have the antecedent on a line. But so I suspect I'm going to get this with modus ponens, and I'm going to use line 1 and something. Now, that something is probably going to be line 4, because that's all that's left. So I know that 4 is going to have to be the antecedent of the conditional, y and w. So how can I get that? So put it here and remove those dang spaces. So how can I get that? Well, I have y and I have w. And the conjunction rule says for any two things that you know are true, you know the conjunction of those two things are true. So one thing I could make is w and y. I could also make y and w from those things, except for this is not the same thing as this. Now, if you're thinking, yeah, but if w and y is true, then y and w is true. That's true. We could prove that anytime a conjunction is true, we could switch the order and that conjunction would be true as well. And if you proved that that is a valid inference, you could, and in particular, both ways. So if w and y is true, y and w is true, and vice versa. They're actually equivalent statements. So if you prove these, it would be a valid inference from one to the other. You could make a rule that just says I can switch the order of conjunctions. We could make infinitely many rules. The reason why we are not using infinitely many rules is because then you start having to remember a lot of stuff. So we're just going to use 5 really common patterns that you'll actually use frequently and stick to that. But for what it's worth, I could also make the conjunction using the rule I have here. I could put this and y. Those are 2 lines I have, line 1 and line 2. I could make the conjunction of those 2 lines as well. The thing is I don't want that conjunction, so I'm not going to do that. Okay, so what you'll do is fill this in. We'll cite, I'm going to remove those spaces. We're going to cite lines 2 and 3. We use the conjunction rule to make that. Then we were able to use modus ponens on lines 1 and 4 to get z. This proof is complete. Okay, so let's look at the next one. We've got the first line is done for us. Let's work through this one backwards strategically. We have A or B. The first thing I'm going to do is see, is my conclusion anywhere in the premises? I notice that it's right here. So I'm going to want to get this on the last line here, and I see that it's right here. It is a disjunct in this broader disjunction. I have a rule that says if I've got a disjunction and I have the negation of one disjunct, I can get the other one on a line. So that means I want not z. If I were writing this out by hand, I'd maybe put a note to myself. I want not z. How can I get not z? Oh, hey, here it is, up here. How could I get that? This is the consequent of a conditional. So if I could somehow get that on its own line, then I could use disjunctive syllogism to get this thing that I want. So now I'm trying to figure out, well, how do I get not z? Well, it is the consequent of a conditional, which immediately suggests to me modus ponens. If I had w, I could use modus ponens to get not z, then disjunctive syllogism to get this, and I'd be done. So how do I get w? Hey, it's part of this conjunction. And I've actually already taken that apart. So this one was given to us, so we already have w. So we can go w, modus ponens gets us not z. We'll cite our lines, of course, 1 and 4, modus ponens. Now that we have not z, we can use disjunctive syllogism to get a or b. So that's 3 and 5 ds, and this proof is complete. And I'm not going to do the final one, but let's just take a quick look at it. So I want z, so I'm sketching into myself, I'm ultimately trying to get z. I see that z is part of this big long thing, but I know that if I'm going to get z on its own line, I'm probably going to need this whole thing on its own line. This is the consequent of a conditional. So if I were to use modus ponens to get that on its own line, I would need w. How can I get w? Well, the only other place w is down here. And actually, I want the negation of this antecedent. That would be w. So I'm thinking modus tollens. To get the negation of this on its own line, I would need the negation of this. And I have that. Other than working backwards, we could just do anything we see. What do we even have to work with? Well, there's 2 conditional statements, so I'm thinking modus ponens and modus tollens, and then just start seeing what I have to work with. Well, this y on its own is likely something I'm going to use. It's the negation of a consequent. Remember that adding or removing a tilde is negating. So this is the negation of this. So I know I can get w right away. Now I have the antecedent of this conditional, so I know I can get the consequent. And I'm trying to get z eventually, and now I have the antecedent of this conditional, so I can use modus ponens again to get z, and then fill in the appropriate justifications and the rules. Okay, so hopefully this is a helpful guide. Good luck completing them on your own, and remember to do lots of exercises and not just the homework.